Okay, now here's a quick video that if we have the limit as z goes to z0 of f of z equals big F, and big F is not equal to 0, then what we can do is we'll be able to show that for some delta, we'll be able to bound the absolute value of f of z. We'll be able to say that that's bigger than f over 2 and smaller than 3f over 2. And actually, you really could come up with any numbers for a given delta. There's, that any numbers I want to pick, there would be a delta that I could bound my function in terms of this limit. And again, well, that kind of intuitively that makes sense, is that if that's the limit, if I get close enough to it, this function should have a value pretty close to that value. And so we're just trying to say, yeah, we can kind of put it in between those two things. So how do we do that? Let's see if I can make that happen. I got to think about it here for a minute. Okay, so let's, again, triangle inequality comes into play. So I can say that f, well, actually, the absolute value of f minus absolute value of big F by the triangle inequality is less than or equal to my little f minus big F. And I can choose to say that that difference is less than the absolute value of f over 2 for some delta. Okay, I don't know what that delta is, but I know that if I choose my epsilon to be this absolute value of f over 2, there exists some delta for which I can make sure that happens because I've got the limit here. And so if that's the case, then just taking this with that absolute value, what that means is that minus the absolute value of f over 2 is less than the absolute value of f minus absolute value big F less than absolute value of f over 2. So I'm just using the definition of that, those outside absolute values with that number there. And so now add this to both sides, and so that's where I get my f is between, oops, not minus, plus absolute value of f over 2, because I add f to that, and between 3 times absolute value of f over 2. So, that's where I can get that inequality. And again, I could actually use any numbers based on that big F that I want. Instead of using ratios, I could say I could make it as close to F, within some number like an epsilon. I could do it that way. But doing it as a ratio of big F is kind of a nice way to go sometimes. So, I can bound that